2.4, which is transformations of linear functions. So a family of graphs includes graphs and equations of graphs that have at least one characteristic in common. The parent function is the simplest of the functions in a family. The family of linear functions includes all lines with the parent function f of x equals x, also called the identity function. A transformation moves the graph on the coordinate plane, which can create new linear functions. One type of transformation is a translation. A translation is a transformation in which a figure is slid from one position to another without being turned. A linear function can be slid up, down, left, right, or in two directions. So the first part we're going to focus on here is going to be when it is a vertical translation. So it says when a constant k is added to a linear function f of x, the result is a vertical translation. The y-intercept of f of x is translated up or down. So then it shows it in a table format. So the graph of g of x equals x plus k. Is the graph of f of x equals x translated vertically? So it's taking our line and either going to be moving it up or down based on some characteristics. So here it says if k is greater than 0. So if it is a positive number, it is going to be moving it up. If k is less than 0, so a negative number, it would be moving it down. If it's 0, it doesn't move it at all. Okay? So it's moving every point on that line by that amount of units. So they want us to take that and look at this part here. So if I look at this equation, it says describe the translation in g of x equals x minus 2 as it represents the graph of the parent function. So we would want to rewrite this. So this would be x plus a negative 2. So this is less than 0, meaning it's going to be moving down. So this would be translated down 2 units. Okay. The next part focuses on horizontal translations. So it says when a constant h is subtracted from the x value before the function f of x is performed, the result is a horizontal translation. The x-intercept of f of x is translated right or left. Okay, so if it's in parentheses like this, then it's going to be going left or right. So when h is more than 0, so when h is positive, it'll be going right. When h is negative, it'll be going left. The difference here, if we look besides the parentheses, is this formula had the plus sign, but this one has a minus, so subtraction. So we need to make sure that it is written in subtraction form so that we're moving the correct way. So when I go to look at this example, it says describe the translation in g of x, x plus 5. So remember, it has to be written as subtraction, so this would be x minus, and to make that a plus, it had to have been a negative 5. Since this is less than 0, that means that we are going left. So we would say left 5 units. Okay. Example 3 is putting both things together. So remember, inside the parentheses, it needed to be written as subtraction, which here it is. And on the outside, it needed to be written as addition, which it is. So, since it's subtraction of a 6, that means it's a positive 6. So this would be telling us to go right. And since this is a plus 3, that would be telling us to go up. So this would be right 6 units, and up 3 units is how they would translate this graph. Okay. So we've talked about our vertical, horizontal just by looking at the equation. So this next part, we have a word problem, which I'm pretty sure we just have to look at the equation here as well. So a website sells tickets to concerts and sporting events. The total price of the tickets to a certain game can be modeled by f of t equals 12t, where t represents the number of tickets purchased. The website then charges a standard service fee of $4 per order. The total price of an order can be modeled by g of t equals 12t plus 4. Describe the translation. So that 4 is not being added inside parentheses or anything. It's being added outside. So since it's being outside and this is plus, this is more than 0, which means this would be 4 units up. So in order for it to have been inside the function, what it would have had to look like, I'll write it down here. It would have had to look like this, 12 and then t plus 4. This would have been when we had to look at if it went left or right. But because it was 12t plus 4, that means it has to be up or down. And since it was plus, it's up. So now we can go ahead and look at if we're going to be, how we're going to dilate. Okay, so far we've just been sliding it. So a dilation stretches or compresses. Another word they use for compress is shrink. The graph of a function. So when a linear function f of x is multiplied by a positive constant a, the result a times f of x is a vertical dilation. So if the a is being multiplied outside of the function, that is when it's going to be vertical, which is the up and down, so it affects y. So if our absolute value of a is more than 1, then it is going to be a vertical stretch away from the x-axis. If it's between 0 and 1, it is going to be compressed or shrunk vertically towards the x-axis. So it shows the brown line was going away, and it shows the green line is going towards. If the a is being multiplied inside our function, so before we actually plug in our value of x, then it is going to be horizontal. And this one kind of works flipped. So if it's more than 1, it's going to be compressed or shrunk horizontally towards the y-axis. So that means this brown line got closer to our y-axis. If it's between 0 and 1, it is going to be stretched horizontally away from the y-axis. So this one got further away. Okay. So I'll explain some of the shortcuts of how I view all translations and dilations. So when I think of this, I look at it and I see if it's inside or outside my function. So like when I look at this first one, the 2 is outside the parentheses. So to me, that means this is outside my function. And if it's outside, it has to affect my y. Well, my y is the vertical. So I know it's going to be a vertical stretch or shrink. Okay. When it affects the y, you do exactly as it says. So if I'm multiplying by 2, I'm making something bigger. So in this case, I would be stretching it. So this would be a vertical stretch by 2. Where when I go to look at this next one, okay, that 1/4 is inside, which means it'll affect my x, which is horizontal. Whenever it's inside the function and it's affecting my x, you do the opposite. Okay? So since 1/4 is usually making it smaller, but it's in the inside, I do the opposite, which means this is a stretch of, and you flip the fraction. So our 1/4 would become 4. The same thing was true when I was doing my sliding. The up and down was on the outside. So if it was plus, I went up. If it was minus, I went down like I normally would. But when it was on the inside for left or right, if it was -6, we actually went right 6. If it had been +6, we actually went left. So it's opposite when it's on the inside, regular when it's on the outside. Okay. So here, for this next part, we also have reflections. Okay. So a reflection is a transformation in which a figure, line, or curve is flipped across a line. When a linear function, f of x, multiplied by -1 before or after the function has been evaluated, the result is a reflection across the x or y axis. Every x or y coordinate of f of x is multiplied by -1. So when it's on the outside here, it is going to be a reflection across the x-axis. And remember, I said when it's on the outside, it affects y. Well, if you look at our y's, they flip sign. Where when it's on the inside, I said it affects x. So when we reflect across the y-axis, it switched my x values. So it's still going to be that same process. So this next one wants us to apply the dilation. So not only are we going to be multiplying it by a number, but they also have us reflect here. So when we're reflecting, this reflection is happening on the outside of the function. So it would reflect, or it would affect our y's. In order for it to affect our y's, we reflect across the x-axis. And since it's affecting y, it's going to be a vertical. This is 1/2, which is less than 0. So this would be the compress or shrink. I'll use both terms because I don't know which one your state test will use. And then of, and since it's on the outside, you do what it says. So of 1/2. So it caused us to reflect across the x-axis and to do a vertical compress / shrink of 1/2. Okay. So this next one says describe the translation. This one's on the inside, so it's affecting my x values. So that means I reflect across the y-axis. And it'll be a horizontal because it's affecting x. Now, since this is a big number and it's on the inside, remember we do opposite. So instead of a stretch, this is actually a compress / shrink of, and remember we have to flip that fraction. So 3 becomes 1/3. So we'll talk a little bit more about this in 4.7, I believe, but that is it for the 4.4 notes.